Alright, so we are looking at binary operations. Now, a binary operation is simply an operation that works on two numbers, just from the word binary, on two numbers. So when you are defining a binary operation, we are going to use the operation star. So we are going to get a statement such as a binary operation star is defined on A and B. So let's say we've got a binary operation star which is defined on A and B, such that if you get A star B, you are going to, this is going to mean that you get A, you square it, and then minus 2B. So this is the meaning. This is just an example I'm giving. So you've got a binary operation star that is defined on A and B, such that if you get A star B, that is going to give you A squared minus 2B. So this means that when you've got two numbers, let's say you've got two numbers 2 and 3. So if you perform the operation 2 star 3, this is going to mean you get the first one. As you can see, A is the first one which came here. So you get the first number that has been given. In this case, it is 2. You square that. And then minus 2, you get now the second number. So the second number in this case is 3. So this is going to give you 4 minus 6, which is equal to a negative 2. So this is the meaning of this operation. This is the meaning of this binary operation. 2 star 3, given this condition. So I can be given another condition. Take for example, they've given you that the operation star is defined on A and B such that A star B is equal to, let's say, A minus B squared plus 2AB. So the meaning of this is when you've been given negative 1 star 3, this is going to mean the first number that you've been given is the one that you're going to write first, negative 1, and then always subtract the second number that you've been given, 3, and then plus 2 times the first number that you are given, that is negative 1, and then second number that you are given, that is a 3. Negative 1, of course there is a square there. Negative 1 minus 3, that's negative 4, and that is squared. And then 2 times negative 1 times negative times positive 3, that is a negative 6. Negative 4 squared, 16 minus 6, that is going to give you a 10. So this is the meaning of this operation, or binary operation star on A and B, given this condition. Now when you are talking about a binary operation or an operation can only be a binary operation if the result of that operation is part of that set that you're talking about. What we mean is this. Take for example, we've got a set A that has got elements 1 and 2, and then you have got, let's say, the set B that has got the elements 0, 1 and 2. You want to perform some additions. Let's say you want to see which one is going to be a binary operation between addition, multiplication, division and subtraction. Which of these is a binary operation on these two sets? To make it simple, let me just use 0 and 1 for B. So I'm going to start with addition. To show that it's a binary operation, what I'm going to do is I'm going to write set A. The elements in set A, we have got 1 and 2. And then I'm going to write set B. The elements there, we've got 0 and 1. And then I'm going to be adding 0 plus 1, that is a 1. 0 plus 2, that is a 2. 1 plus 1 here is a 2. And then we have got a 2 plus 1, which is a 3. Now, an operation is only a binary operation on a certain set if the result is always part of the same sets. Now, when you add set A with set B, we are seeing these here you are able to see are the results. We have got 1, 2, 2 and 3. Now 3 is not part of these two sets. Because the 3 is not part of these two sets, meaning that the operation plus is not a binary operation on these two sets. That's the meaning. It's not a binary operation. So let's try to do multiplication. So we're going to get A, which is 1 and 2, and then we're going to get B, which is 0 and 1. 0 multiplied by 1, this is 0. 0 multiplied by 2, this is 0. 1 multiplied by 1, that's 1. 1 multiplied by 2, that's 2. So you can see that the result, we have got 0, 0, 1, and 2. And all these results are part of the sets. So the only way an operation is going to be a binary operation is if the result is always part of the same set that you add at the beginning. So meaning that this result that you have here is part of A and B, meaning that multiplication is a binary operation on the sets A and B. That is how you get to do it if they ask you to see if an operation is a binary operation. Let me give another example. Let's say we've got a set S which is equal to 1 and 2. We want to find out if division, let's say addition, multiplication, subtraction, and division are binary operations on these sets. So to find out if they're binary operations, I'm going to write just the same elements I'm seeing here, 1 and 2. I'm also going to write it again, 1 and 2. We are going to multiply them. 1 multiplied by 1, that's a 1. 1 by 2, that's a 2. 1 by 2, that's a 2. 2 by 2, that's a 4. So I can see 4 is not part of this set, meaning that multiplication is not a binary operation on the set S. Let's see addition. We have got 1, we've got 2, again 1 and 2. Now we are adding 1 plus 1, this is a 2. 1 plus 2, that's a 3. 1 plus 2, that's a 3. 2 plus 2, that's a 4. This again, we have got 3 and 4, they are not part of this set. So this is not a binary operation again. We can talk of subtraction. Now for subtraction, we have to draw two tables because we are going to understand. We have got 1 and 2, we have got 1 and 2, we are subtracting. So if we start from here, 1 minus 1, that is going to give us a 0. 1 minus 2, that is going to give us a negative 1. If we start with this one, 2 minus 1, that is going to give us a positive 1. So take both directions, and then 1 minus 2 also is negative 1. If we take the other direction, it's going to be positive 1. 2 minus 2 is 0. So you can see we have got a negative 1 here, which is not part of this set, meaning that subtraction is also not a binary operation. Even division is not going to be a binary operation. We have got 1, 2, 1, 2. We are now dividing. So we say 1 over 1, that is going to give us 1. 2 over 1, that is going to give us 2. And then we also say 1 over 2, that is going to give us a 0.5. If we come here, 1 over 2, that is 0.5. And then 2 over 1, that is going to be a 2. If we say 2 over 2, that is going to be a 1. So you can see the 0.5 is not part of this set, meaning that division is not also a binary operation on the set S. So the only way an operation can be a binary operation is if the result after performing the operation is always part of the set. We can continue increasing our set. The set which I've given here is a limited set. It has only two elements, 1 and 2. Now what if we're talking about a set of integers? You want to find out if addition, subtraction, division, and multiplication are binary operations on those sets. So integers are numbers starting from negative numbers to positive numbers. They don't include decimals, they don't include fractions. These are all numbers. For example, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, like that. Not 0.5, that's not an integer. Half is not an integer. So only whole numbers from negative to positive. So if you are talking about division on the set of integers, meaning that if I get any two integers, I divide them, I should always get an integer. Is that true? If you think of 1 and 2, these are two integers. If I say 1 over 2, I'm going to get half, and half is not an integer. So If they asked you to prove that division is not a binary operation on a set of integers, just get any two numbers that you are going to divide that will not give you an integer, then you have proven. So this is not a binary operation on a set of integers. Let's talk of subtraction. If you're talking about subtraction, get any two integers you can think of. For example, 1 and 2. Let's subtract them. We're going to get negative 1. Is negative 1 an integer? Yes, it is. Let's get 2 and 1. Let's subtract them. We're going to get 1. Is it an integer? Yes, it is. Let's get 0 and 5. We subtract them. Is it an integer? Yes, it is. So any two numbers that you are going to get and subtract them, you are always going to get an integer as long as they are integers. So subtraction is a binary operation on a set of integers. If you talk of addition, if you get any two numbers, you add them. Any two integers, you add them. The answer will always be an integer. Negative 2 plus 5, negative 3 minus negative 4. Any number 0 plus 7, as long as you add two integers, you always get an integer. And every time you multiply two integers, you always get an integer. 0 times 5, 5 times 1, 2 times what? It always by an integer. So it's only division which is not a binary operation on the set of integers. Is that okay? Do you have questions? All right. I hope that